Welcome to The Explainer. Today, we're going to crack open the researcher's toolkit. We're going to find out how we actually know what we know. How do scientists get those reliable, trustworthy answers to some really big questions about our world and even about ourselves? So, let's start with a question you've probably wondered about yourself. Does jamming out to music while you study actually help you get better grades? It seems simple enough, right? But how would you find a real scientific answer? You could ask your friends, sure, but that's just going to get you a bunch of opinions. If you want to get to the truth, well, you're going to need the right tools for the job. And that's really the whole game right there. To get from a simple question to some real, solid knowledge, researchers have this whole set of proven methods they can turn to. But here's the secret. The key is picking the perfect tool for the question you're trying to answer.
All right, let's really get into it. The best way to think about all of this is like a researcher's toolbox. You wouldn't use a hammer to saw a piece of wood, would you? Of course not. It's the same idea here. Researchers have to pick the right method for the job. And it turns out pretty much all these tools fall into two main families. And this is the big one. It's probably the most important distinction in the entire toolkit. It all boils down to one simple question. Are you going to just sit back and watch the world as it is? Or are you going to jump in, change something, and see what happens? So here we have it, side by side. On one hand, you've got non-experimental research. This is all about observing. You're just watching and describing the world as it naturally exists. The researcher doesn't touch a thing. Then you have experimental research. This is all about intervening. Here, the researcher is actively messing with something, manipulating one variable to see what effect it has on another. It's the difference between watching the rain and trying to make it rain. Okay, so let's grab that first set of tools from our non-experimental tray. These are the ones all about describing things, about just painting a really clear picture of reality.
This first tool is called descriptive research. Think of it as the foundation for everything else. Its whole job is to answer one question. What is happening? It's like taking a snapshot of a situation. A national census or a survey on unemployment rates. That's descriptive research. It gives us the what, the essential facts and figures we need to even begin. But, just describing something is usually just the start. Once we know what's happening, the very next question is almost always, I wonder if these things are connected. And to answer that, we need to pull out a different tool. That next tool is correlational research. This is where things get really interesting, because now we're looking for patterns and relationships between different things. For instance, is there a connection between the number of hours you study and the grade you get on your final? Correlational research is perfect for spotting that kind of relationship. But, and you really got to listen to this part, it comes with a massive warning label. And here it is. I'm not kidding. This might be the single most important rule in all of science. Correlation does not equal causation. You're going to hear this a lot. Just because two things seem to move together doesn't mean one is causing the other. This is, without a doubt, the easiest trap for us to fall into when we look at data. This is the classic example that shows you exactly why this is so important. It's a fact. When ice cream sales go up, so do the number of drowning incidents. They are perfectly correlated. But does that mean eating a pint of Rocky Road makes you a bad swimmer? Of course not. There's a hidden factor, right? A third variable that's causing both things. Summer heat. It's hot, so people buy more ice cream, and they also go swimming more often. See how easy it is to get it wrong? So if we want to get past just finding connections and actually prove that X causes Y, we have to put down the observation tools. It's time to open up the other side of the toolkit, experimental research. This right here, this is the gold standard for proving cause and effect. A true experiment is all about one thing: control. Here's the basic recipe. You create at least two groups that are as identical as possible. Then, you change just one single thing for one of the groups. That one thing you change is called the independent variable. And then you measure the outcome. If there's a difference between the groups at the end, well, you know exactly what caused it, because it was the only thing that was different. But okay, even within the powerful world of experiments, researchers face a huge choice. It's this constant battle. A trade-off, really, between perfect control and messy, complicated reality. And this slide lays that choice out perfectly. On one side, you have the lab experiment. This happens in a super controlled artificial setting. You get a ton of control, which is great for being sure about cause and effect, but it's not exactly the real world, is it? People might act differently. On the other side, you have the field experiment. You take your test out into the real world. It's way messier and you have way less control. But the upside is huge. What you find is much more likely to be how people actually behave. So what do you want? Pure, clean results from a lab, or messy but realistic findings from the real world?
All right, so let's do a quick check of what's in our toolkit now. We've got descriptive research, which helps us see what is. Then there's correlational research, which shows us if things are related. And finally, the big one, experimental research, which lets us figure out what causes what.
And honestly, this is what I really want you to take away from all this. Understanding the tool that was used to get an answer is just as important as the answer itself. The next time you see a headline about some amazing new study, don't just look at the conclusion. Ask yourself how they found it. Knowing the method tells you everything about how much you should actually trust the results. So I want to leave you with this. The next time a big study hits the headlines, what's the very first question you're going to ask about how it was done? Was it descriptive, correlational, or was it a true experiment? Just asking that simple question makes you a way smarter, more critical thinker. It's your key to navigating a world that's just full of information and misinformation.